Hello everyone. In this video tutorial, I want to show you how to generate your layouts with maps and cross-sections for printing in Leapfrog. For this, I have chosen a geological model that we have built together in the last classroom session. This is a model of a region which is faulted, and you have a vein cross-cutting the layers. So we will generate a rendered geologic map of the model, and we will draw a cross-section, finally putting the two on a layout for printing. Before I start with rendering a geologic map, I want to show you this lighting effect on the model. As you can see, when I rotate the model, you have a source of light, and that light is reflected from the surface, giving it a shiny three-dimensional surface. While it's very useful when visualizing a model in a 3D scene, it is not as useful when you're printing your map on a two-dimensional piece of paper. So for a rendered geologic map, we would first switch off the light and then render it. To do that, we need to go to the settings menu of Leapfrog Geo here in the left upper corner of the main window. So when you click on main menu, you have an option settings. So you click on settings option, and then a pop-up window appears showing you all kinds of settings that you can control. The one that we are interested in is called lighting. When you activate lighting, you have several options for controlling your lighting. So as you can see here, we have light 1 and light 2 on. And these are the light sources which produce this shiny surface on the model. So we need to switch them off. So we switch the two off, and we can see that the model or the map is quite dark and it's hard to see it. That's because the ambient level is low, and we need to increase that ambient level to see the map clearly. So we can increase it to 1 to maximum. Since we switched off the light, then there is no source of light, external one. So then the ambient level should be high enough to clearly see the map. Okay, so when we increase the ambient level, everything is clearly visible, we can close the settings window and return back to our scene. Okay, now we are ready to produce our rendered geologic map. What does rendered geologic map mean? It means that we render this view into an image, and that would be a static image that we cannot, of course, rotate in 2 dimensions, and it would be a 2-dimensional map. As the map we loaded and digitized this model from. So this map we initially loaded, it's also a 2-dimensional map. So we will create a similar map like this. Okay, so to create that map, we need to add it to GIS data folder, because this map will be also a GIS sort of map. So we right click on this GIS data folder and choose new rendered map. And it offers us to define the extent of the map we want to render. By default, it covers the full extent of the model, and that's fine with us for now. Then we can also change settings, or image size, basically, size settings. So here we have 1 megapixel size by default. This is the smallest one, and it produces the smallest size map. In this case, it's 3 megabytes, and if we print it on A6 paper, it would be with a resolution of 200 dpi. A resolution of 200 dpi is fine for printing, but since we are printing on an A4 paper, or we want to print it on an A4 paper in our case, we need to slightly increase the resolution, and I'll set it to 4 megapixels. As you can see, for a 4 megapixel image size, it will weigh around 13 megabytes. And if you print it on an A4 paper, the resolution will be 200 dpi. And I think that's okay for us, so we can click OK now. Once we click OK, the map is rendered, and it can be found under the folder GIS data, and we named it simply map. So here it is. Let me switch off the model to show you the map. So I drag and drop the map onto the scene, and as you can see, the map is rendered, and if I rotate it, you will see that it's a two-dimensional surface, a two-dimensional map. So the rendered map is ready to be placed on a layout. Okay, but to print it, we need to have a layout itself, right? So we need to then create that layout. So here in the project tree, you have a folder called Sections, Plans, and Contours. And obviously this rendered map that we just produced, it's a plan view of the model. So it will be under this folder, Sections, Plans, and Contours. So we right click here and we create a new plan view. So when we create a new plan view, it again asks us to specify the extent of the plan view, and by default it covers the full extent of the model, and that's fine with us. So we then can rename this plan view. I want to rename it to geological map, let's say, and I click OK, and so my plan view is now generated. So if I click if I double click on plan view, then you can get to the settings of the plan view and can change everything we just defined. But for me, I want to have a layout to edit to see how it looks like on a paper. So to do that, I right click on the geological map plan view and click on new layout. And a new layout will create a paper sheet on top of which it will visualize our map view. So as you can see, it has created this layout with the frame of the map, but we first start by defining the size of the paper, and we want to print it on an A4 paper. So then we can click on page. Here, as you can see on this panel on the left, you have different settings for the layout. So the first one would be page. If you switch to page tab, you can see down here some settings for the page, and the first thing to change would be size of the page, and we want to set it to A4. And then, as you can see, the plan view has got larger than it should be, so we can then fit it to section. So then it will fit to the page. But our page is in landscape view, in landscape mode of orientation, so we want to change it to portrait. All right, so when it's changed, you can see that on the page we have several items visualized. First one is the frame of the map itself. Second, we have legend here. Third, we have location. Fourth, we have scale. And then we have the title of the map and the north arrow. So to visualize the title of the map, let's move a little bit the frame of the map down so that we can have some space for the title. We can position it in a desirable position. And then up here we can see we have a north arrow too. So we bring the north arrow in here. Okay, because the extent is covering the full extent of the model, I can then get rid of this location box that I don't need because it's covering the full extent. But if you have partial extent of the map and you want to specify which part of the model you're visualizing in here, the location would be useful to have. So in this case, I will just switch it off, and by simply selecting the location, you need to select it on the page, and then when you select it, the location tab on the left panel will be activated, and in the bottom part you'll see the settings related to this location. So then you can simply switch it off by checking this visible option. Okay, location is off now. We have legend, and we have north arrow, we have scale bar. Okay, but we don't have our rendered map in here yet, so we need to visualize it. To do that, we can add a map here. As you can see, our plan view may have many different types of data visualized on it. And in this case, I want to visualize the map we just rendered. So I need to right click on the maps and add maps, and then here choose the map I want to add. In this case, I want to choose simple map, not map 17-fold modified, but map. This is how I named my rendered map. Okay, I click OK, and then you'll see that the map is now visualized in the frame. All right, so then the legend is empty because we haven't yet visualized anything for it, because our map is a rendered image, so it doesn't have any distinction between the polygons and their color, so that's why it's not shown in the legend. But we will show it with a cross section, so for now, again, I will switch it off, the visible, so there is no legend for us for this rendered map. But we'll have it for the cross section, and the cross section will show the same units, and we'll have it. Okay, so our rendered map is ready. We can now move on to drawing our cross section. So to finish layout preparation for this rendered map, I need to click on Save button to save my changes. So I save, and then I close the layout I was working on. So I close it, I get back to the main scene, and now I can draw a cross section. So the cross sections are also drawn on the same, under the same folder, sections, plans, and contours. So we right click on sections, and then we choose new cross section. So here again, similar to rendering a map, it will offer you options to change or to define the extent of the cross section. So as you can see on the scene now, we have these controls to change the position of our cross section. I wanted to cross not only the layers but also the fold, so then I can now rotate it to bring it diagonally, so it's crossing both layers and the fold. Okay, so then when I do that, I can then rotate it. Okay, so I need to, yeah. When I do that, so there is some problem with visualization on my PC, but I guess let me do it once again, because when defining the extent of cross section, as you can see, it went too deep, so it cannot rotate it, and that's because the height is too large. So I can get back to the plan view now here. The height is too large, so I will set it to, let's say, 1000, so that it will have a 1000 meter height on the model. And as you can see, it has, it goes from around plus 1000 and above, but that's because our model is not loaded, so it doesn't know the depth. So let me load the model and adjust it relative to that model. I'll switch off the rendered image. As you can see, it's above the model, but it should be within the model. So I'll use this blue arrow to bring it down, right? And then I can modify its extent again to bring it to the bounding boxes of the model. As you can see, it doesn't go to the bottom of the model, and that means I can now slightly modify its size by clicking on the red arrows and dragging them down to the bottom of the model. Okay. Okay, so then it goes now from the northwestern corner of the model to this, southwestern to the northeastern corners. Okay, so then when the extent of the cross section is defined, now I can move on and name it. Let's call it northeast, southwest cross section. Okay, and then click OK. Make sure that the dip of the cross section is 90, because the cross section is normally vertical, unless you want to make it inclined. In that case, you can change it to any angle you wish. But in this case, we want to keep it 90 degrees, and we can click OK for the cross section to be built. And as you can see in under the folder cross sections, plans, and contours, we have our new cross section generated. And I will clear the scene and bring in this cross section to see what we have. So as you can see, it's empty because it hasn't yet evaluated any model. And the cross section is created for the model domain, but we haven't yet specified what do we want to visualize on this cross section, which model. To do that, we'll right click on the cross section and choose evaluations. The cross section needs to evaluate objects, and we can choose different objects. We can choose topography, we can choose surfaces, mesh surfaces, and we can choose model. So in this case, I want to visualize everything in geological model that we built. And to do that, I choose the model and click on this arrow pointing towards right. And this will move an object from a list of available objects to the list of selected objects. Okay, then you click OK, and the cross section will then evaluate the model, but it will still not show the proper cross section here because we haven't yet chosen it. And as you can see under this layers tab here, our new cross section is visualized using flat color, and the color is shown here, but we want to visualize it by the evaluations of the model. So we can then click on the arrow of color, choosing, and then we can choose geologic model. As you can see now, our model is visualized, and we can clearly see our layers, their displacement, and we can also see the vein. All right, so now the cross section seems to be ready, and we need also to create a layout for it to be visualized on. So as you can see here, if I uncollapse the cross section under the sections folder here, you will see that it doesn't have any layout. So we need to right click on this cross section and choose new layout. So this will create a new layout for our cross section and visualize the cross section in here. Okay, so again, similar to our geologic map, we can start with defining the size of the page, and I click on the page here, and down here I choose size A3 now, not A4, because I also want to place our geologic map on the same layout, and that's already A4, so I need to have a bigger size to place both cross-section and the geologic map. So I will then click on the cross-section and slightly reduce it in size. And then I have space on the left for the geologic map. Okay, so I'll leave all these for now, and I will focus on bringing the plan view here and then evaluating the cross-section. I'll start with the plan view. So then, as you can see on the left side again on the panel of available objects and items, we can have an option called, a folder called plan views. This will allow us to bring the plan view we created earlier, geological map, onto this layout. So I right click on this plan view, choose add plan view, and then click on geological map that I created earlier. Then I click OK. And the plan view is brought in. All right, now I need to get rid of this title new. Well, actually, we will need it for the cross section, yes, so we can keep it. And so then I will bring the cross section to a desirable position. And then we again need to slightly change its settings. For example, as you can see, coordinates down here, we don't need them. So we can choose cross section, come to its x-axis. And so here we can change some settings here. Okay, so on the x-axis, we don't want to show real-world coordinates, so we can switch it off. And then we can also come down here to switch off the axis labels, so we can switch them on and off. If we need, we can keep them. In this case, I want to keep them. And then we can then change the settings of the y-axis. So here, as you can see, we have, again, real-world coordinates switched on, and it's better to switch them on. And so in this case, we show only z coordinates, not x and y. We don't need them on the y-axis. And then, as you can see, the primary axis on the left is shown. This is the primary axis. And on the right side, the secondary axis is not shown, but we want to show it. So I click secondary, and that shows. And so, but I don't need these grid spacing, so I want to switch them off. And you can uncheck this grid lines to get rid of those grids on the y-axis, and do the same for the x-axis to get rid of the grid lines. Now the cross-section frame is ready, but we need to bring in the cross-section, and that's where we evaluate objects for the cross-section. And so then if we choose the section here, we can see that under the section we have folder called models. And so that we want to add our model in here as we added earlier. So we add model, and we choose geologic model. We click OK, and the cross-section is now visualized. All right, and so one thing to notice is that on the map that is positioned on the left, we now have the line AB showing the position of the cross-section. All right, and then one more item that is added onto the layout. It might be hiding below the geological map plan view, so make sure that you find it and bring it to the right to make it visible. So now we have scale, we have location, we have legend, and we also have the title for the new cross-section. All of them are positioned on a single layout and are ready for printing. So we then, when everything is ready, we can click on Save button to save the layout, and our layout is ready for printing. Okay, so but then if you want to fine tune any item in here, you can click on any of these items and change their settings. But one thing to notice is that when you click on the plan view, you cannot select any of these individual items separately. So to change them, you need to go and open geological map, plan view, actually not the plan view itself, but its layout. You need to uncollapse it to see the layout. So you double click on the layout opens, and you can change any settings. For example, here I wanted to have it the legend without decimal points. So you click the legend in here, and for the values, okay, scale bar, apparently it doesn't allow us. It changes it automatically, but okay. So yeah, if you want to change the settings here, you can change them here. So then here, as you can see, our scale is with decimal points, but we don't want them. So we can change the scale by selecting the plan view here in the joint layout which is created. And so then here we can set it to, let's say, 25,000. Click OK, and our plan view has changed its scale, and everything is okay. All right, I think that's it for this video tutorial. Thank you, and see you next time.